Hello, and thank you for joining me on this short pre-recorded webinar. I'm Rebecca Wanjoey, Head of Maths at Manchester Communication Academy. Today, we're going to explore how we can use talk to improve mathematical thinking at Key Stage 3. This session is grounded in the Education Endowment Foundation guidance and focuses on practical strategies that you can use straight away in the classroom. Let's begin with a key idea. Pupils don't learn maths just by doing. They learn by thinking, explaining, and connecting ideas. The challenge for us as teachers is that we can't see that thinking unless pupils articulate it. High quality talk is an effective strategy that can make that thinking visible. The EEF Improving Maths in Key Stage 2 and 3 guidance is clear that effective maths teaching requires more than procedural fluency. It requires understanding how pupils are thinking and using that to shape teaching. So improving talk isn't an add-on to everyday teaching, it's central to improving pupil learning. I'd like you to pause and reflect. When do your pupils do the most thinking? Pause the video whilst you reflect on this. So, is it when they're working silently? Or when they're explaining, justifying, and responding to each other? The EEF guidance emphasises that pupils need to communicate their reasoning and reflect on their thinking, and that only happens when we deliberately create opportunities for talk. The evidence is really clear that high-quality talk supports learning in several ways. High-quality mathematical talk supports learning by helping pupils solve problems more effectively, develop deeper reasoning, and identify and address misconceptions. When pupils are given opportunities to explain their thinking and discuss different approaches, they are more likely to engage in the kinds of processes highlighted in the EEF guidance, such as analysing strategies, making connections, and reflecting on their methods. This not only strengthens problem solving, but also exposes misunderstandings, allowing teachers to respond and adapt their teaching. In this way, talk becomes a key mechanism for developing both conceptual understanding and mathematical reasoning, rather than simply arriving at correct answers. EEF guidance highlights that pupils should be supported to explain their thinking, reflect on the strategies they use, and communicate their reasoning clearly to others. These processes are essential for developing a deeper understanding of mathematics, as they require pupils to make sense of their ideas rather than simply follow procedures. Crucially, the guidance also emphasises that pupils need to monitor and evaluate their thinking, checking whether their approach is working, considering alternative strategies, and reflecting on the effectiveness of their solutions. This is a core aspect of metacognition, and structured talk in the classroom plays a vital role in making this thinking explicit and supporting pupils to develop these skills over time. To structure our high-quality talk tasks, we use the TOLD framework from the EEF: take part, opportunities, links, and debate. This provides a simple, practical way of thinking about how we can develop high-quality talk in the mathematics classroom, ensuring that discussion is purposeful and focused on learning. The framework reflects key principles from the EEF guidance, including the importance of active participation, problem solving, building connections, and addressing misconceptions. It gives us a clear model for what effective mathematical talk looks like in practice, which we will now explore in more detail. First, take part. This is about ensuring that all pupils are actively involved in the learning, not just a small number of confident contributors. The EEF guidance emphasises that pupils need to take an active role in their learning and develop independence and metacognitive skills, which means thinking about and reflecting on their own understanding. If only a few pupils are contributing, we are missing most of the thinking in the room, and we limit our ability to identify misconceptions and support all learners effectively. In practice, this means deliberately structuring participation so that every pupil is required to think and contribute. This might include using cold calling in a supportive way, giving pupils time to rehearse their ideas through think, pair, share, and establishing clear expectations that everyone will be involved in discussion. The goal here is not just participation for its own sake, but thinking participation, where every pupil is engaged in processing, articulating, and refining their mathematical ideas. Second, opportunities. EEF guidance on problem solving highlights that pupils need opportunities to compare strategies, analyse different approaches, and reflect on their thinking. This is crucial because problem solving is not just about reaching an answer, it's about understanding the process, recognising underlying structures, and making informed decisions about which methods to use. Without these opportunities, pupils may rely on memorised procedures rather than developing genuine mathematical understanding. This means that as teachers, we don't just plan tasks, we plan the questions that will drive thinking. Questions such as, how do you know? Why does this work? And is there another way? Prompt pupils to explain, justify, and explore alternative approaches. These types of questions move us beyond simple answer getting and into deeper reasoning, helping pupils to develop a more secure and flexible understanding of mathematics. Third, links. EEF guidance emphasises the importance of developing a rich, connected network of mathematical knowledge rather than teaching isolated skills or procedures. When pupils make connections between ideas, representations, and prior learning, they are more likely to develop a deeper and more flexible understanding of mathematics. This helps them see the underlying structure of the subject, rather than viewing each topic as something separate. In the classroom, this means deliberately prompting pupils to make those connections. We might ask questions such as, who can build on that? Or how is that similar to something we've seen before? To encourage pupils to link their thinking. This supports them to recognise patterns and structures, generalise ideas across different contexts, and ultimately transfer their knowledge to new and unfamiliar problems. Finally, debate. EEF guidance is very clear that misconceptions need to be identified and addressed directly, rather than avoided or worked around. Pupils often hold on to misconceptions because they are built on partial understanding that seems logical to them. If these misconceptions are not surfaced and explored, they can become embedded and limit future learning. Debate provides a powerful way to bring these ideas to the surface and refine understanding. By encouraging pupils to justify their thinking, respond to others, and consider alternative viewpoints, we create opportunities to challenge misconceptions and deepen reasoning. Questions such as, do you agree? Is this always true? And convince me, prompt pupils to engage critically with mathematical ideas. It is through the process of explanation, challenge, and refinement that deeper learning takes place. When all four elements come together, we begin to see what high-quality mathematical talk looks like in practice. Multiple pupils contributing, rich explanations being shared, clear connections being made, and purposeful challenge through discussion. This is where pupils are not just participating, but actively thinking, reasoning, and refining their understanding. However, this doesn't happen by accident. EEF guidance reminds us that tasks alone do not drive learning. It is how teachers use those tasks, through questioning and interaction, that has the greatest impact. So we need to deliberately design for talk, planning not just what pupils will do, but how they will think, discuss, and respond to one another. Let's look at an example. Is 1/3 plus 1/4 equal to 2/7? This is a powerful question because it exposes a common misconception that pupils can add numerators and denominators separately. EEF guidance highlights that misconceptions are often rooted in partial truths, meaning they make sense to pupils based on prior learning. Because of this, they need to be explored and unpacked through discussion rather than simply corrected, so that pupils can build a more secure and accurate understanding. Let's walk through how this might look in a real classroom. Take part. We begin by ensuring that all pupils are actively engaged. Pupils first think individually, then discuss their ideas in pairs, and finally share with the class. This structure is important because it gives every pupil time to process their thinking before speaking. EEF guidance highlights that developing metacognition requires pupils to plan, monitor, and articulate their thinking, and structured talk like this supports that process by making thinking explicit rather than rushed. Opportunities. We then introduce purposeful questioning. For example, we might ask, why might someone think this is correct? This is a deliberate question. It normalizes error and shifts the focus from simply being right to understanding reasoning. EEF guidance emphasizes the importance of discussion and reflection in developing understanding, particularly in problem solving, where pupils need to analyze approaches rather than just produce answers. Links. Next, we help pupils make connections. We might ask, how does this link to equivalent fractions? Or where would these fractions sit on a number line? EEF strongly supports the use of representations, particularly number lines, as a way of developing conceptual understanding. Through this discussion, pupils may begin to realise that 1/3 is larger than 1/4, and therefore 2/7 cannot be a reasonable answer. This is a key moment where conceptual understanding is emerging through talk rather than being directly told. We then deepen the thinking through debate. Questions like, convince me, why is it wrong? Or, can anyone challenge that explanation? Encourage pupils to justify, critique, and refine ideas. EEF guidance highlights that comparing strategies and explanations is a powerful way to deepen understanding, as it requires pupils to engage with the underlying mathematics rather than surface features. At this point, the role of the teacher is crucial. The teacher is listening carefully to pupil responses, identifying misconceptions, and selecting which ideas to bring to the whole class. EEF emphasises that assessment through discussion is a key tool for adapting teaching in real time. This is not just talk, it is diagnostic teaching. This is where the impact really comes in. EEF highlights two key principles. First, misconceptions must be explicitly addressed. And second, representations can support pupils in making sense of abstract ideas. So when we deliberately combine structured talk, careful questioning, and purposeful use of representations, we move pupils from giving superficial answers to developing deep, connected understanding. The first strategy is to plan key questions, not just tasks. EEF guidance on problem solving emphasises that pupils need opportunities to compare approaches, analyse different strategies, and reflect on how effective their methods are. This means that simply giving pupils a set of questions to complete is not enough to develop deeper understanding. Instead, we need to think carefully about the questions we ask during the lesson. These questions should prompt pupils to explain their thinking, justify their choices, and consider alternative approaches. For example, rather than asking, what's the answer? We might ask, why does that method work? Or which method is more efficient and why? By planning these questions in advance, we ensure that pupils are not just completing work, but actively engaging in reasoning and problem solving. In this way, it is the questions, not the worksheet, that drive thinking. The second strategy is to use talk moves. Talk moves are simple but powerful prompts that help to extend and deepen pupil thinking. They support pupils to explain their ideas more clearly, challenge the thinking of others, and build on contributions within the classroom discussion. For example, prompts such as, can you explain that again? Do you agree or disagree? And can you build on that idea? Encourage pupils to engage more actively in the discussion. Rather than accepting answers at face value, these moves push pupils to justify, critique, and refine their thinking. This aligns closely with EEF guidance, which highlights the importance of communication and reasoning in mathematics. By using talk moves consistently, we create a classroom culture where pupils are expected not just to answer, but to explain, challenge, and extend ideas. The third strategy is to build structured talk time into lessons. EEF guidance highlights the importance of metacognition, pupils planning, monitoring, and evaluating their thinking. However, pupils need time and structure to do this effectively. If we expect immediate answers, pupils often respond quickly without fully processing their thinking. Instead, we need to deliberately slow the thinking down. This might involve structures such as think, pair, share, where pupils first consider a question independently, then discuss it with a partner before sharing more widely. Or explain, refine, improve, where pupils articulate an idea, receive feedback, and then develop it further. These structures give pupils the time and space to process, articulate, and refine their thinking. As a result, talk becomes more thoughtful, more purposeful, and more effective in supporting deep learning. There are some important pitfalls to be aware of when developing talk in maths, and these matter because if we get them wrong, talk can actually limit learning rather than improve it. First, limited participation. This is where the same pupils contribute repeatedly, while others remain passive. The risk here is that we only access a small proportion of the thinking in the room. EEF guidance emphasises that all pupils need to be actively engaged in thinking and learning, not just observing others. If participation is limited, we miss valuable opportunities to identify misconceptions, develop reasoning, and build confidence across the whole class. This is why strategies such as cold calling and think, pair, share are so important. They ensure that every pupil is required to think, not just a small number of volunteers. Second, shallow questioning. This is when questions focus only on getting answers rather than developing understanding. For example, asking, what's the answer, instead of why does that work? EEF guidance highlights that pupils need opportunities to explain their reasoning, compare strategies, and reflect on their thinking. If questioning remains too closed or procedural, pupils may arrive at correct answers without understanding the mathematics behind them. So the key shift here is from answer checking to understanding checking. Third, unstructured talk. Sometimes we encourage discussion, but without a clear purpose or structure. This can lead to off-task conversation, superficial explanations, or confusion rather than clarity. EEF guidance is clear that talk needs to be purposeful and well-structured to support learning. This is where frameworks like TOLD are valuable. They help ensure that talk includes participation, reasoning, connections, challenge. So the aim is not simply to talk more, but to talk better. Fourth, cognitive overload. This occurs when pupils are asked to process too much at once, tackle too many ideas simultaneously, or respond too quickly without time to think. EEF reminds us that learning is limited by working memory. When pupils are overloaded, talk becomes rushed and superficial rather than thoughtful and meaningful. To address this, we need to break ideas down into manageable steps, build in deliberate thinking time, use structures such as think, pair, share. These opportunities allow pupils to process, articulate, and refine their thinking more effectively. So the key message is this. EEF reminds us that effective teaching isn't about doing more, it's about doing the right thing with precision and clarity. When talk is carefully structured and deliberately planned, it becomes a powerful tool for improving mathematical thinking, not just an activity within the classroom. As we come to the end of this session, I'd like you to take a moment to reflect. What is one change you will make to improve the quality of talk in your maths lessons? EEF guidance is clear that talk is not an add-on, it is central to learning maths well. When pupils are given regular... As we come to the end of this session, I'd like you to take a moment to reflect. What is one change you will make to improve the quality of talk in your maths lessons? EEF guidance is clear that talk is not an add-on, it is central to learning maths well. When pupils are given regular opportunities to explain their thinking, reflect on their opportunities, and make connections between ideas, they develop a deeper and more secure understanding of mathematics. These processes, explaining, reflecting, and connecting, are consistently highlighted in the evidence as essential for moving beyond surface level answers towards genuine understanding. So, even small changes, such as adjusting the questions we ask or structuring opportunities for discussion, can have a significant impact on pupils' thinking and learning. Thank you for listening. I hope this session has provided you with practical, evidence-informed strategies that you can take straight into your classroom. If you want any further information or support, please don't hesitate to get in touch with Manchester Communication Research School.